In this video, we're going to take a look at selection in computational thinking for IGCSE computer science. So in case you didn't watch the first video, what I've said on the previous one is that the pseudocode syntax may be slightly different depending on the exam board that you're with, however the theory is still the same. So as we said before, we've got abstraction, decomposition and pattern recognition as three key things for computational thinking for us to break down and solve a problem. Then to get our ideas down where we can actually start developing it, we create an algorithm which should then get translated usually into some form of program using a high-level programming language. So just like before, we've got our and, or and not logical operators. So we have two conditions, so condition 1 and condition 2. So it could be if x is greater than y and x is equal to z, do something. You've got your or, which is first condition or second condition. So it could be if x is greater than y or x is equal to z. And then you've got not, so that is essentially swapping the output. So if x is greater than y, we would then, instead of returning true, we return false. So then we've got our relational operators. We've got equals, greater than, less than or equal to, greater than or equal to, and then greater than or less than, which can also be said is a not as well. So these two symbols here is like not. So if we put that symbol 5, for example, so it might be if number less than greater than 5, then if you typed in 5, it would be false because it's not 5 essentially. Whereas if you put in any other number, it would return true. So that's when you sort of want to do a not essentially. Now, selection is where we choose to do one sequence or another based on a condition, and you'll be using this in your everyday lives. So if it's raining outside, you're going to stay indoors. Whereas if it's sunny, you might go out on your bike and go for a bike ride or something like that. You're constantly using it when you're making decisions. If you're hungry, go to the fridge. If you're tired, go to sleep. If you're not tired, don't go to sleep. It's just choosing things to do based on a condition in our lives. And this is how programs are written to make their own decisions essentially. So we've got if, then, and else. So we'll start off with just an if, then. So an if, then is where if a certain condition is true, then you take a particular action. So this one might be, if number greater than 10. If it's true, we'll say the number's greater than 10, well done. If it's not true, then it will carry on, won't do anything. It'll just carry on as normal. Then an example in pseudocode is we're going to declare a variable called user number, which is an integer. We're going to have a constant, so this is a like a variable but not a variable that can't change. So it's a fixed number, so we wouldn't be able to change this code ever. It's a piece of memory or a piece of data storage that can't be changed. We're going to input our user number, so the user's going to type a number in, and if that number is greater than 5, so greater than a fixed number, it's going to output the number is greater than 5. Now, if there's no other code after this, you just wouldn't say anything. So you take the number in and the program wouldn't do anything essentially. It'd look like it's finished. Whereas if there was code after this, it would just ignore this part and carry on as normal. Then you might have an if, then, else. So this is where if the condition is true, you do one thing. If it's false, you do something else. So we've got a forename and a surname, so F name, S name, and gender. So if we input our words, and then if the gender is F, it'll output hello miss, and then surname, may I call you by forename. If you typed in anything else, so if you typed in Z, X, M, it would output hello Mr, may I call you, and the same sort of thing. So it will choose to only do this piece of code if gender is equal to F. Otherwise, it will always say this. Doesn't matter what you type in, even if you typed in nothing, just press enter, it would still output hello Mr. And then we have a thing called a select case, where it's very similar to having lots of if statements, where it takes a particular action based on a condition. So it might be if you type in 1, it does action 1, 2, action 2, 3, action 3. It basically, instead of us having a massive huge if statement, we can have a big case statement. So it looks a little bit like this. So we've got a score, maybe in a game. Now, in the case of you getting a score of 0, 1, 2, 3 or 4, it will output no new score. If you get 5, it'll say you've match the high score. If you get anything else, if you get 6, 7, 8, 9, 10, a million, it'll say you beat the high score. Now you don't have to write it 0, 2, 4. You could write 0, 1, 2, 3, 4 separately as well. This is just to compress it a little bit. But the idea is you can have lots of case statements that allow your program to do different things based on that criteria. And then we can have a nested if. So this is where if a certain condition is true, then we could conduct a second different if statement. Now it could go on this side as well, it could be if it's false, but if you think we could have, is the score greater than 10? If it is, great, we go here. Now is that score greater than 20? If it is, we say, well done, you got a score greater than 20. Here we could say, well done, you got a score greater than 10. And here might say, your score was less than 10. So it allows us to have more conditions and do more sequences based on the criteria we've set. And you can have an unlimited amount of nested if statements. The only issue is it can get quite confusing if you've got lots and lots of nested if statements. So an example here, we've got a boolean which allows us the computer to continue the program. So it might be if boolean's true, it's going to keep going. If it's false, then maybe you've clicked a button or said you don't want to continue, and you've got your options, maybe like a menu option. So if continue is true, so they've chosen to carry on with the program, then we output an option, pick 1, 2 or 3. You then type in that option, and if the option's 1, then you do something. And then you could have, else if option's 2, else if option's 3, else, and so on. So you can combine a nested if statement with an if else as well. We could sort of use all the above. You could even take this part out and put in that case statement if you wanted to. So you could have an if statement and then a case statement. That's absolutely fine. So take a look at the pseudocode written here. So the idea is it's some sort of exam grader where if you get over 50%, you pass. If you get less than 50, then you failed. So pause the video for a second and try and spot what's wrong with this piece of code. So first things first, I've done 2 examples. Now the first one I've got is really it should be greater than or equal to, because if the pass mark's 50% and you get 50 in the old program, then if you actually got 50, the answer would be you would have got an output of fail. So it should be greater than or equal to. What I've also done as well is instead of having 2 if statements, we've gone if else, because if you don't get greater than 50, then you can't have passed, so it must be a fail. So that's a much more compressed, nice, efficient way of writing that if statement. But then we could also have just, if you didn't want to put the greater than or equal to, we could swap it around and have, if you get less than 50, so 49, 48, 47, we output fail, anything else, output pass. So that's 2 ways we could have improved that pseudocode, which in turn would improve the efficiency of our program. It'll make the code a lot easier to read, nicer to understand, and essentially, I would say, better. So don't forget to subscribe and like if you found that helpful. If you haven't watched the previous videos, make sure you do, and we'll be continuing with pseudocode and algorithms in the next video.